Humidity. Water vapor present in the air is known as humidity. Absolute humidity, the actual amount of water vapor present in the atmosphere, represents the mass of water vapor per unit volume of air, measured in grams per cubic meter. It depends entirely on the temperature of the air, greater over the ocean and less over the continent. Relative humidity, percentage of moisture present in the atmosphere as compared to its full capacity at a given temperature. Specific humidity is the mass of water vapor per unit mass of air. It is preferred over absolute humidity as it doesn't change with changes in the condition of temperature and pressure. Saturated air, 100% RH holds maximum moisture at that temperature. Any moisture in excess causes condensation. Saturation is achieved by raising absolute humidity, adding moisture, or lowering temperature. Unsaturated air, less than 100% RH holds moisture below max capacity, can absorb more without saturation. Dew point, the temperature at which saturation occurs in a given sample of air. Evaporation and condensation. Evaporation. The process by which water is transformed from liquid to gaseous state. Latent heat of vaporization, the amount of heat that is required to convert a unit mass of liquid substance into a gaseous phase at constant temperature conditions. Factors influencing evaporation. Higher temperatures lead to increased water absorption and retention capacity in a given volume of air. Air with a lower moisture content has the ability to absorb and retain moisture. The movement. 9. Water in the atmosphere. The continuous transformation and circulation of water among oceans, the atmosphere, and land is referred to as the water or hydrological cycle. Distribution of water in percentage. Oceans, 97.3, ice caps, 2.0, groundwater, 0.68, freshwater lakes, 0.009, inland seas and salt lakes, 0.009, atmosphere, 0.0019, rivers, 0.0001, UPSC 2021. 40. Water in the atmosphere. Of air replaces saturated air with unsaturated air, which promotes evaporation. Consequently, greater air movement results in higher rates of evaporation. Evaporation variability. Factors like temperature, air pressure, wind, and water salinity impact evaporation rates. Globally, oceans have higher evaporation due to extensive coverage. Evaporation decreases from equator to poles. The western North Atlantic shows the highest rates. Condensation. Process of transformation of water vapor into water, caused by the loss of heat. Sublimation. Process of condensation of water vapor directly into the solid form. Conditions for condensation. Temperature of the air reduced to dew point with its volume remaining constant. Both the volume and the temperature are reduced. Moisture is added to the air through evaporation. Condensation nuclei. Small particles in the atmosphere that provide surfaces for water vapor to condense, e.g., dust, smoke, pollen, and salt. Factors influencing condensation. Air movement, temperature. Lower temperature favors condensation, humidity. Higher humidity promotes condensation, altitude and pressure changes. Forms of condensation. When dew point, freezing point. Outcomes are dew, fog, and clouds. In when dew point, freezing point. Outcomes are white frost, snow, hailstones, and cirrus clouds. Dew, when the moisture is deposited in the form of water droplets on cooler surfaces of solid objects, rather than nuclei in air above the surface. Dew point is above the freezing point. Ideal conditions for its formations. Clear sky, as clouds will reflect back the long wave radiations coming out of the Earth's surface, thus keeping the Earth warm. Calm air, high relative humidity, and cold and long night. Dew point, freezing point equals formation of frost. UPSC 2019. Ideal conditions for the formation of white frost. Same as those for the formation of dew, except that the air temperature must be at or below the freezing point. Fog, essentially a cloud that forms either at or extremely close to the Earth's surface. Occurs when the temperature of an air mass with a substantial amount of water vapor suddenly Drops, leading to condensation on tiny dust particles within the air mass itself, prevalent in areas where warm currents of air come in contact with cold currents. Drier than the mist. Ideal conditions. High humidity. Dew point and presence of condensation nuclei. Types of fog. Cooling fogs, radiation fog, formed due to night cooling, advection fog, when warm air moves over cold surface, upslope fog, when air rises over a slope, orographic lifting. Evaporation fog, steam fog, forms over warm water, common over lakes. Z-mist, more moisture content than fog, occurs in moist air, greater than 75% humidity, short-lived, common over mountains. Z-haze, reduced visibility, linked to low humidity, less than 75%, caused by uneven light refraction and industrial particles. Z-smog, combination of smoke and fog, caused due to urban/industrial air pollution, grayish, brownish, hazy appearance. 3 types: classical, London, photochemical, summer/Los Angeles, and VG, volcanic smog. Classical smog, caused by coal combustion, high concentration of sulfur dioxide and particulate matter, weather conditions, cold and humid climate. Photochemical smog, a mixture of pollutants that are formed when nitrogen oxides and volatile organic compounds, VCs, react to sunlight, creating a brown haze, creates secondary pollutants, ozone, PAN, and aldehydes. VG, volcanic smog from volcanic eruptions, hazy mixture of SO2 gas and aerosols. Clouds. A cloud is a collection of small water droplets or tiny ice crystals, 0.02 millimeters, that result from the condensation of water vapor in the open atmosphere at a significant altitude. They have a dual impact: cooling reflecting sunlight, and warming trapping heat. Types of clouds. Cirrus, they are thin, separate clouds with a delicate, feather-like appearance. Develop at elevated heights, 8,000 to 12,000 m. Always white and composed of ice crystals. Nimbus, formed at intermediate altitudes or extremely close to the Earth's surface with no specific shape. Water in the atmosphere 41. Have a dark, black, or deep gray coloration. Possess an exceptionally dense and sun-blocking opacity. They are shapeless masses of thick vapor. Cumulonimbus, with its strong vertical updraft, extends well into the high level of clouds. Stratus, extensive, layered clouds that envelop significant sections of the sky, generally formed either due to loss of heat or the mixing of air masses with different temperatures. Cumulus, cumulus clouds look like cotton wool and have a flat base, generally formed at a height of 4,000, 7,000 m and exist in patches. A combination of these 4 basic types can give rise to the following types of clouds. High clouds, cirrus, cirrostratus, cirrocumulus. Middle clouds, altostratus and altocumulus. Low clouds, stratocumulus and nimbostratus. Clouds with extensive vertical development, cumulus and cumulonimbus. Fig, classification of clouds. Other clouds. Lenticular clouds, formed by wavy airflow around obstacles, with a lens or saucer-like shape and defined edges. Formation involves wave development, adiabatic cooling, condensation, and evaporation. Crucial indicators of turbulence for pilots. Polar stratospheric clouds, PSCs, formed in winter in the polar stratosphere, 15,000 to 25,000 meters, with a composition of ice crystals and liquid droplets, displaying an iridescent, mother-of-pearl appearance. Noctilucent clouds, NLCs, formed in the mesosphere, 80 to 90 kilometers, Earth's highest clouds, composed of ice crystals, visible only at night and illuminated by scattered sunlight, known as night shining clouds. Thick, low clouds mainly cool down the Earth's surface by reflecting solar radiation. High, thin clouds, in addition to transmitting incoming solar radiation, also retain part of the outgoing infrared heat that the Earth emits and reflect it back downward, warming the Earth's surface. UPSC 2022. Precipitation. Precipitation refers to the release of moisture that occurs after the condensation of water vapor. Rainfall, precipitation in the form of liquid water. Z snowfall. When the temperature is below freezing point, precipitation takes the form of fine snowflakes. Z sleet consists of frozen raindrops or refrozen melted snow water. Occurs when there's a layer of air with a temperature above freezing point overlying a sub-freezing layer near the ground. Z hailstones, formed when rainwater droplets solidify into small, rounded pieces of ice while passing through colder layers, typically have multiple concentric layers of ice. Z freezing rain, drizzles or light rains occurring below 0 degrees Celsius temperature and being frozen before reaching the ground. Z virage, raindrops evaporate before reaching earth and dry air. 42 water in the atmosphere. Types of rainfall. On the basis of origin. Z convectional rainfall. Warm air rises due to convection currents, expands, cools down, and subsequently undergoes condensation, resulting in the formation of cumulus clouds and precipitation. Prevalent during the summer or in the warmer hours of the day. Particularly common in equatorial regions and the inner regions of continents, especially in the northern hemisphere. Heavy rainfall accompanied by thunder and lightning occurs, but it tends to be of shorter duration. Z orographic rainfall. Relief rainfall occurs when a moisture-saturated air mass encounters a mountain and is compelled to rise. With ascendance, adiabatic expansion and cooling takes place, resulting in condensation and precipitation. More rainfall towards windward slopes, while on the leeward side, rain shadow area, adiabatic heating, temperatures increase, takes place, allowing for greater moisture absorption and resulting in dry conditions without rain. Area situated on the leeward side is known as the rain shadow area. Z cyclonic rainfall. Widespread precipitation associated with weather fronts and cyclones, includes tropical and extratropical cyclonic rain. World distribution of rainfall. Z rainfall diminishes steadily from the equator towards the poles. Z equatorial regions receive consistent year-round rainfall. Z coastal areas receive more rainfall than inland regions. Z between latitudes 35 degrees and 40 degrees north and S, eastern coasts get heavier rainfall due to easterly winds, decreasing westward. Between 45 degrees and 65 degrees north and S, westerly winds bring rainfall first to western continental margins, decreasing eastward. Rainfall regions. Z heavy rainfall, greater than 200 centimeters annually. Equatorial region, coastal monsoon region, windward side of coastal mountains. Z moderate rainfall, between 100 to 200 centimeters annually. Adjacent regions of very heavy rainfall areas, coastal regions in the warm temperate region. Z inadequate rainfall, between 50 to 100 centimeters annually. Eastern part of the continents in temperate regions, interior of continents in tropical regions. Z low rainfall, less than 50 centimeters annually. Rain shadow regions, western part of continents in tropical regions.